I would like to take a few minutes to explain and go over assignment 3. So let's take a look at that. Assignment 3 is a calculator. Now, I'm not talking about the kind of calculator that you use in math class or the kind that's on your phone where you do like 2 plus 6 equals and then it gives you the answer. I'm talking about a calculator that calculates a specific thing. If, for example, you wanted to buy a new car and you're like, I know how much money I make each month, and I know how much money I have in savings for a down payment. Can I afford this car payment? You might use a car payment calculator to figure that out. That's the kind of calculator that I am wanting you to do here. So there's lots and lots of different types of calculators that you can use, like a currency converter, like if I have $100 in US dollars, how many euros is that? You can do something like that. You could do a temperature conversion. So if 100 degrees Fahrenheit is how many degrees Celsius, kind of a thing. You can do an interest, car payment, mortgage calculator. You can calculate the volume of a solid shape. You could calculate the area of a triangle. You could calculate all kinds of things. Those formulas are widely available online. So all you have to do is choose something. Now, I will give you credit for calculators that only take one input from the user. I would prefer that you challenge yourself and get at least 2 inputs from the user. In other words, something like a currency converter only takes 1 input from the user, like how many dollars do you have, and then it spits out how many euros. An interest calculator might take the interest rate and the down payment of a car or something like that. So you want to think about things that have multiple inputs. If you want something simple that has multiple inputs, calculating the area or the volume of most shapes takes multiple inputs, right? The area of a rectangle is the length times the height. So there are lots of different things that you can calculate. Like I said, I will give you credit for 1 input, but I'm going to challenge you to push yourself a little bit and find some things that have 2 inputs. So you want to find out what the formula is, and you want to figure out how to express that formula in Python, because when you see the formula online, if it's in an equation format, it might have some things that are very complicated. So you might need to break it up into pieces. You might need to do separate calculations and then combine them. You'll need to figure that out. You need to do the calculation, print the result, and then you want to test your code, obviously, before you send it in with some different numbers and see if it makes sense. So let's see how that looks here. Let's say I'm going to choose the easy one here, and I'm going to take a area of a rectangle, print. So I'm going to start challenging you to think about your user experience. So when somebody uses your program, like if you take this calculator to your mom and say, hey mom, I made a calculator, you want to try it out? You want her to have an experience that gives her some understanding of what it is she's doing. You don't want it to just say, give me the length, give me the width, because the length and width of what? What am I doing here? So you want to give your user some kind of experience. So welcome to my rectangle area calculator. And then I'm going to put a \n inside the string at the end of this. And what that does is it puts another blank line beneath it before it prints something else. That n, that \n is a special character that says, it's like hitting return one more time at the end of that line. So now I'm going to length, it's going to be input. What is the length. Okay. And I'm going to say int height. I'm going to abbreviate. What is the height? Okay. And then I'm going to say int answer equals int height times int length. Now, this is kind of yelling at me a little bit here. It's like, I don't really like that. Why is it yelling at me right now? Why might not Python be happy with the code I've written? What's that?
Right.
Okay. That's true. But there's a problem here because I'm trying to do math and I'm telling you that these are ints, but what are they actually? What type? They're strings. Right now I'm trying to do math on a couple of strings. So I need to do some conversion here or else I'm going to have an error. And I'm just going to do it right up here, right where I'm gathering the input. Now, this is a little bit risky because if somebody types something that is not a number, I will get an error here. If they type something here that cannot be converted to an int, I will get an error. So it's a little risky. In this case, for the sake of simplicity in this program, we're all going to be okay with taking that risk. In the future, we're going to learn how to error-proof our programs so that if somebody types something that's not okay in there, it says, whoa, you can't type that. Let's try a number instead.
Or by not giving them an option for a number?
You can't. With input, they can type literally anything or nothing. So you have to actually catch it after the fact. You have to say, did they type in a number?
Okay.
And if they didn't, what are we going to do with it?
Okay.
But for now, we're just going to trust the user, which is always dangerous, to do something useful. Okay? So the last thing I need to do here is to print out my little F string here, the area of your rectangle is, and I'm just going to put int answer right in there, just like that. And that is an example of what assignment 3 would look like if I was going to do a rectangle area. So let's run that. There's my little welcome message, 10 by 20. So the area of the rectangle is 200. Okay? So that is assignment 3. You must have at least one input, preferably 2 or more. You must do some kind of calculation, and you want to print out the answer. And now we're starting to think about how are we giving the user some context and some understanding of what it is they're supposed to do. Because we're thinking about software development. We're not just writing code. If we were just writing code, all we would care about is that the code works. But when we're creating software, we think about it differently. We want to think about who's going to be using this, what kind of instructions do they need, what kind of context do I have to give them so that they know what they're doing. Okay? So again, I'm trusting the users, but if I did something like this, I'm going to immediately get an error because the word 10, T-E-N, even though it means a number, cannot be converted into an int. Okay, so we'll learn how to prevent that in the future, but for now, we're just going to blindly trust that our users know what they're doing. Okay?
If you were to do string length and string height, then could you enter 10 right now instead of int?
Yes, but then I could not do
The math.
math.
Okay.
So
All right.
instead of getting the error here, I would get an error here.
Okay. Right.
hmm
Okay.
So what I would, if I was building a super intelligent program, I would teach it to recognize the words for numbers
Right.
and convert them to digits that way. But now my little 5-line program here just turned into like 1,000 lines of code or more
Okay.
to to figure that stuff out.
All right.
So it gets a little sticky, right? Okay. So yeah, that's assignment 3, and you have about 20 minutes to work on these two things, sandbox and assignment, and we will move on to module 4 next week. So make sure that you're keeping up and